Good day everyone. Ang among topic is sampling preparations. The general considerations in sampling, accuracy and precision, and sensitivity. Now just an overview lang, di ba? Ang ato subject karon is techniques in metallurgical analysis. Now ang among topic is mag-focus lang sa preparation of the sample before jud ang main analysis. Now, there are different ways to prepare the sample. Why? Because kibayo na kita na there are different ores, different purposes, and different methods that will be discussed later. Like let's say you wanna quantitatively determine the metal contents of gold, then kabalo na kita na proceed kita sa FAR assay. And there are three general steps in FAR assay: the preparation, collection, and separation. Now sa preparation stage, we have to crush or mill ang ore samples para mahimo siya na fine powders. Kay pag ma-fine powders na siya, dali na lang siya i-mix sa other components such as litharge and reducing agents para ang atong ore sample magkaroon ng homogeneity. Now, i-discuss later nganong importante ang homogeneity ng samples. Then, as for the important of the topic, ang mining industry, nag-collect na sila samples to assist with decision making, whether for exploration, resource estimation, or grade control. And not only that, because ang sample preparation can improve analytical results. Kaya if may error sa preparation, maapektuhan ang accuracy and precision ng imo results, then maapektuhan ang reliability ng imo analysis. Objectives. At the end of the lesson, the student should be able to first know what is sampling preparation and the general considerations in sampling, differentiate accuracy and precision, understand the importance of sensitivity in sampling, then remember the topics for further discussions. Definition of terms. Sample is just a finite part of a statistical population. Iba naman kita na like population ng animals or population ng plants, or sa ato case kay ang ore deposit. Ang sample is just a portion of the bigger picture, which is the ore deposit. Then sampling. Sampling is just the process of collecting samples and then analyzing them to determine the quality or composition of a material. Then ang matrix is the sample or specimen received as such for analysis. It contains other elements or compounds in complex combinations besides the species of interest. In short, ang matrix is, di ba natay, species of interest. Anything na nag-revolve sa species of interest, mauna siya ang matrix. Now, ang analyte, on the other hand, mauna siya ang species of interest na ato kailangan i-analyze. Then, ang accuracy and precision. Accuracy is just kung unsa kaduol ang imong result sa target value. Then, ang precision is unsa kaduol ang imong result with each other. Later on, i-discuss na further ng ako groupmates.
At this point, I am going to discuss to you the general sampling considerations. So the mining industry collects sample to assist with decision making, whether it is for exploration, resource estimation, grade control, or plant design and balances. So sampling is highly needed for us to be able to monitor and determine the grade of the ore. Remember that poor sampling can hinder the production and monitoring of environmental impacts. So, these are the general sampling considerations. First, a sample should be homogeneous and representative of the material of interest. So the sample should be homogeneous so that the process of sampling will be convenient and easy to determine the characteristics of an ore sample due to their uniformity. It should be available in sufficient quantity for testing of the required parameters. So there are required parameters in testing the samples. Thus, we have to secure enough samples Just in case there is a mistake in the process, there is more available sample to cover up. Also, it is important that sample integrity should be preserved between sample preparation, collection, and analysis. So the integrity of the sample should be preserved because this is the basis of determining the limits of our sample. Also, we have to ensure minimal loss due to evaporation, contamination, or degradation. The sampling container should be cleaned and rinsed before collection of the sample. So before picking up the samples, the sampling containers should be properly cleaned and rinsed because if it is contaminated with dirt and other unwanted materials, and will be involved or included to the sampling process, it may negatively affect the result or the interpretation of data. And I believe we don't want that to happen. Most importantly, we have to equally and properly labeled with indelible ink, and label should bear essential details regarding the sample. So we have to equally label to avoid confusions of the data of our samples. To achieve better quality result from the sample should be properly handled with care. It should be properly documented to avoid mashups of data and confusions. We have to check always the status of our samples, secure enough samples to sustain the required parameters. Since this may also be dangerous, we have to wear protective gears to protect yourselves from dangers. Analyte removal. So analyte, it is the object of the analytical procedure. It is considered as the interest or sample or the subject of chemical analysis. We have to remember the purest substances are referred to as analysis. Several sample extraction techniques are in use presently. First, we have liquid. It is the solvent extraction and partitioning, a method to separate compounds or metal complexes based on their relative solubilities into different immiscible liquids. It is usually water and an organic solvent. Solid. Liquid extraction such as SPE, DSPE, and SPM. SPE stands for solid phase extraction. It is a sample preparation technique routinely used in analytical laboratories for the extraction of analytes for a complex matrix. This sample preparation technique enables the extraction, cleanup, and concentration of analytes prior to their quantification. DSPE stands for dispersive solid phase extraction. This is used as a pretreatment technique for the analysis of several compounds. This technique is based on the dispersion of a solid solvent in liquid samples in the extraction, isolation, and cleanup of different analytes from complex matrices. SPM stands for suspended particulate matter. It are finely divided solids or liquids that may be dispersed through the air from combustion processes, industrial activities, or natural sources. Precipitation. This occurs in aqueous solution when two ions bond together to form an insoluble salt. Distillation. It is the process of separating the components or substances from a liquid mixture by using selective boiling and condensation. Sample preconcentration or dilution. Pre-concentration is to increase the concentration of a sample prior to analysis or detection. This is also to support the concentration process. Dilution, on the other side, is the process of decreasing the concentration of a solute in a solution. This process keeps the amount of a solute constant but increases the total amount of solution, thereby decreasing its final concentration. There are instances that samples may contain solid particles that could cause clogging of the chromatographic columns or orifices in analyzing systems such as in ICP-MS. So, to prevent that from happening, the samples are taken in a syringe and filtered through a filter membrane. Thus, the filtrate is collected in a clean rinsed vial. Sample storage. Note, it is important to bear in mind that even the most sophisticated instruments will produce erroneous results if proper precautions are not taken in the sample preparation and handling stage. So start analysis at the earliest after sample preparation or collection right away. Take adequate precaution for storage of temperature or light sensitive samples and store samples in prescribed containers. Otherwise, samples can get contaminated during storage. Samples are also taken as a basis for determining the limits of ore bodies and also for the distribution of valuable minerals within them and for estimating the tonnage and value of ore within the explored area. Up next,
Next is types of sampling. Now in sampling, we have mainly three types. They are chemical sampling, technological sampling, and technical sampling. First is chemical sampling. This type of sampling, by the word chemical, it is a process that involves chemical procedures or process. Samples are applied with chemical procedures such as assaying, which will be tackled in the next group. Next is technological sampling. This sampling involves the processing of samples through technologies or instruments to determine the properties, content, and significance of the difference between two analytes, the sample of interest, which can be done through analytical balance. Last is technical sampling. By the word technical and the relation of studying it, basically you study the properties of a raw material or a sample such as its volume, size, metal content, and the properties of its metal content. For short, hanapon nimo ang mga deeper properties ng mga samples. This process does not require metallurgical or chemical treatment. Why? Because you are just taking notes and basically you're just studying the samples. Next is the methods of sampling.
Methods of sampling. The first method of sampling that I will talk about is the grab sampling. Grab sampling is also known as a catch sample. It consists of a single sample taken at a specific time. This is the most common type of sampling. Kibali ng grab sampling, dili ra ini sa lupa ginagamit nga procedure but pwede sab ini siya sa water sampling. For the purpose nga para mahibalaan ang lain-lain nga parameters sa water quality sampling like pH level and TSS or the total suspended solids. Kaning grab sampling magamit during pre-sampling at any portion sa ore for the purpose nga para makuha ang preliminary idea sa grade sa lupa. Tanan grab sample moagi pananlain sampling for grade confirmation before ma-add to sa stockpile area or pier yard. Basin maglibog ka mo o kalainan ng pier yard sa nan stockpile area. Ang stockpile area kay gikan sa mine pit tapos diretso sa stockpile area. Kibali ang stockpile area amo daw ng imbakanan ng mga ores na wala pa schedule for loading. Sa nankuhaan pa daw otro ng sample. After makuhaan og sample, diretso na siya sa pier yard. Kay naaman sa balaod na dili pwede mag-stock og ore sa causeway kung wala pa schedule sa shipment sa ore. Naaray allowable days nga maximum of 30 days depende sa ECC sa company. Ang pier yard amo na daw ng stock na daw sa causeway. Kay naa naman siya sa causeway, pasabot naka-schedule na siya for shipment. But kung makarga na ang ore sa LCT, daon pa isa ka test, adisir siya makarga sa foreign vessel. Ang tawag daw na test is scan test. Diha may bawaan kung wet ba or dry ang lupa. Kay kung wet ka ra daw ang lupa, ma-reject ang ore nga gikarga sa LCT. Subject to sun drying ang ore. So makita niyo sa picture, ing ana ang pagkuha ng grab sampling. Gamay ra na portion sa lupa ang kuhaon. Next is the coning and quartering. Kaning coning and quartering, amo na ini ang gikan sa phase sampling nga niagi o grab sampling. Amo na ini bali sidya ang naka-stockpile sa stockyard. Para na ini bali sa dagko na stockpile. For example, dyan idyo makita sa amri sa kilid sa dayan. Then, ang process niya kay i-divide into 4 segments. Tapos kung na-divide na nimo into 4, ang 2 opposite corners kay kuhaon para himuon og sample. Tapos hangtod makakuha ta ng suitable sample volume sa ore. Sinako na ang kuhaon nga sampling ani tapos dayhon dajon sa asay for another analysis. Procedure of coning and quartering. First is dapat naa kay approximate 50 kg sa ore but dili na necessary 50 kg. Pwede ra siguro let's say mga 20 kg nga na. Next, mag-set up ka ng area nga duol sa imo kuhaanan og sampling. Kay balik-balikon man nimo ini hangtod makakuha ka ng suitable volume sa ore nga imo tagnid. Sunod kay mag-prepare ka ng clean steel plate. Sunod, tapos imo na dajon i-mix ang lupa pagtarong. Tapos kung na-mix na nimo ang lupa pagtarong, imo na dajon sidya i-quarter or i-divide into 4. Tapos aton ako tag-mention ganihan na diri na nimo kuhaon aton 2 opposite sides para sa imo sample. Tapos i-repeat na dajon ang procedure hangtod makakuha ka ng suitable sample volume na imo tagnid sa next procedure. So, makita niyo sa picture. Magporma ka ng conical hip shape sa lupa or dyan pinakone na shape. Tapos, i-divide na dajon into 4. Tapos, atong 2 opposite side, makita niyo sa picture, kuhaon as sample. Tapos, atong 2 opposite side, i-disregard. Channel or groove or trench sampling. It is the most accepted method of sampling which best suited to bedded, banded, and vent type of deposits. Kasagaran nga sampling ginagamit sa vent type ore like gold mining, especially during exploration and for advancement of drift. Advancement of drift is generic term dyan siya sa mine opening kibali. For example, for ventilation. In some cases, the channel may also be cut along the line making a small angle with thickness of deposits. The procedure involves the following steps. Next slide please. First, dapat hinlo aton expose sample nga gikuha or kuhaon. Next, if necessary, imo i-trim or cut ang sample nga imo kuhaon. Tapos after nimo pagkuha sa sample, dapat naa kay markings. Pwede ra nimo butangan og stick nga naay flag. Finally, excavated material is collected. Pulverized carefully and sampling sites are labeled. As you can see in the picture, on the left side, after niya magkuha ng sample, butangan niya ng tagging. Kung kabantay ka mo dyan, red flag na ija tagbutang. Tapos, sa right side photo, amo dyan ang pagkuha ng sample sa vent type ore. Ginatigtig ang bato hangtod makakuha og suitable volume sa ore nga ginid para sa ore sampling.
Chip or point sampling. The method or this method is less laborious and used as a regular method of known samples, and it is used for hard or uniform ores where it is difficult to cut channels. In this method, the samples are collected by taking a small series of chips of rocks on a regular grid pattern from the working face in regular intervals. The blasted, broken materials are sampled. The shape of grid is adapted to the morphology and the structures of the deposit. The main advantage of this sampling is its high productivity. So, this sampling or the chip or point sampling is a sampling method which is using pattern or points to collect chips of or small series of rocks to be tested. And this method is a less laborious method. Ang point sampling or chip or point sampling is a method siya na which is magkolekta ng mga gagmay na chips or rocks na daon sa point or sa pattern nga different intervals para siya matest. Less siya ng kahago sa journal sampling o taas ija productivity.
This is an actual sample on how chip or point sampling is done.
Phase or mock or lump sampling. The term phase sampling covers sampling of exposed phase of ore and waste. This method of taking samples may be referred to the group of point sampling. One of the three lumps of rocks are gathered in the phase are taken from a pile of broken minerals with the purpose of finding deforming minerals and also the chemical composition. It is very simple, quick, and cheap procedure, but the accuracy of this method is very low. So, isa siya ka sampling method na gamit para lang sa exposed phase sa ore or sa mga outcrops tapos jay man jaon mga lumps or bukdo-bukdo gado sa mga bato or rocks. Kuhaan jaon para i-test kung naabay or na jaon nag-exist sa non-ija chemical composition. Easy siya na method pero ang ija accuracy or level is dili kung duol sa measurement sa standard. Bulk sampling. This type of sampling method is used in checking the reliability of other types of samples and sometimes may be taken to determine a correct factor for use in an estimate based of samples of other types. The samples are taken by blasting down drift blocks or a section in a stope or otherwise obtaining samples of several tons to several hundreds or even thousands of tons either from trench, pit, channel or from the run of mine where the entire lot is milled separately. Bulk sampling is isa ka method na diin nakabase sa inena method kung uno ka reliable o kalidad ang mga samples ug ang ibang mga method kay isa sab ini ang mokolekta sa mga samples or information sa uban nga mga method nga dinaghan dili na kung pareha sa chip or point sampling na mga chips of rocks siya i-test na sample. Dili na dagko na volume sa samples ang i-test kay jaon mga blasted material from drift blocks and stopes is also an information from other methods just like point sampling na jaon dry ore nga na mahibaw-an na dry ore tas pasabugon man jaon ang mga blasted material amo jaon kolektahon hundreds or libo-libo ka tons pila ka trucks ang kuan makuha na mga samples amo jaon ang i-test. Drill hole sampling. This method is more convenient for the determination of the deposit's boundaries. Here, samples consist of the cuttings from drill holes. The samples are usually collected beyond the walls of underground working with a constant across or cross-section. Drill hole sampling or drill hole sampling method are classified based on a type of equipment employed, just like drive pipe, trend drilling, rotary drilling, and also percussion rock drilling. Planar sampling. This method is relatively rare procedure employed on deposits having a very low content of useful minerals. So, drill hole sampling, isa siya ka sampling method na magdig o magdrill siya sa surface or sa underground walls para i-measure kung uno kalayom o haita man ang ore body. Sanan, para matest or makuhaan ng samples ang mga na-recover nila na rock na nadaya sa drilling machine or sa rotary drilling machine or chan drilling. Then, sa planar sampling, isa siya ka procedure or method na applied lang sa mga deposit na grabe kaubos ang content sa mineral. Example is gold.
In this part, we will present and discuss to you all about the accuracy and precision, which is another main subtopic of sample preparation. And we will discuss it to you why accuracy and precision is important in preparing samples. So, accuracy. Basically, accuracy it is the degree or how your measurements close to target value or how close you are to your real value or target value. However, you are not precise. Now, in precision, basically, it is how your measurements will repeat the same value or repeats the exact same value but not close to target. It means that you are not accurate. So why accuracy and precision is important? First, let us discuss why it is important in life. It is important because in the things we do or work, such as answering math questions, experiments, and even informations we gather on news in internet, it should be right to avoid mistakes and troubles. Now, why accuracy and precision is important in sampling preparations and analytical procedures, such as assaying. Being accurate and precise in preparing your sample about the size, the process it should undergo, or ang pag-label nimo is important because it helps a smooth operation throughout the analytical procedures, which can lead to a great or better and more reliable results, basically to avoid mistakes. This is why it is important also in analytical procedures na accurate and precise ang mga data and measurements of solutions so that the process is on point and there should be no faults will exist. Also, it is important that you must be accurate and precise in laboratories to avoid risk or harm, basically for safety purposes. Now, accuracy and precision are not the same thing. As you can see in the picture, understandable na ni siya, masabot na nimo. So accuracy is true to intention. Why? Because it is close to your target value. As you can see sa mga arrows targets niya, suod siya sa center or the bullseye or your true value. Now precision, true it to itself ka kaya imo mga targets or mga basically if you compare it to the results, it is the same. It is nagbalik-balik ra imo mga results. However, dili ka true sa imong intention or dili ka target sa dili ya nimo nakuha ya nimo na achieve an imo target value. Now when you say you have accuracy and precision, you are both accurate and precise, then this way you can achieve your true value. As you can see in the picture, na target niya ang center or the bullseye. Now the following slides will just be examples of determining accuracy and precision. So we have this first example. So measuring a book that has a true length of 17 centimeters. So Susan has 17 centimeter, 16 centimeter, and 18 centimeter, and 15 centimeter. Amo niyang ija measurements sa ija book. No kan ami is 15.5 centimeter, 15.0 centimeter, 15.2 centimeter, and 15.3 centimeter. Now, haman diri sa duha ka measurements ang accuracy but not precise. And haman diri ang precise but not accurate. So Susan's measurement shows accuracy but low in precision, while Amy's measurement shows precision but low in accuracy. So here is another example. So in yung example, magamit nato ini siya or ma-relate nato ini siya sa sample preparation. Like paghanap sa density ng sample. Like for example, the known density of sample is 3.11 grams per milliliters. So the first test result is 3.77, 3.81, 3.76, 3.80. And its average is 3.785. So precise siya but not accurate. So as you can see sa mga measurements niya nagbalik-balik. So sa second test results, 3.01, 3.89, 3.50, 5.99. So ang average is 4.12. So neither. Ladyo siya sa imo true value. Now, the third test result is 3.11, 3.12, 3.13, 3.12, 3.10. The average is 3.1125. Now you are close to the value, which means you are accurate. However, you are not precise. Now in the last results, you have 3.04, 3.20, 3.13, 3.07, and the average is 3.11. Now, we can see in these results that you are both accurate and precise.
Reason for accuracy or precision being off. We have human error and instrument error. So in human error, we have parallax error and mathematical error. So in human error, it is an action that has a given negative consequences or mga mali na ma-achieve ang isa ka desired outcome. In human error, there are two types, which is parallax error and mathematical error. So in parallax error, the apparent shape and position when view at the different angle. And also, parallax error occurs when the measurement of the object length is more or less than true length because of your eye being positioned at the angle to the measurement markers. So mauna na ang parallax error mo occur siya depende kung asa ta nakaposisyon ang ato mata, kung wala sa correct na position ang ato mata sa pagkuha ng measurement ng isa ka object. And also, cause of parallax error is when the observer movement relative to fixed background, because when the observer moves, it's look like the object is at a different place, which is example diha sa picture na makita nato sa PPT na ay liquid thermometer. When reading of temperature, some people look from above and some people look from below. But there are not the right ways of reading temperature, which is the right way is reading from eye level. So example na kung ang correct line of volume is 70 degree, diha nakaposition 70 degree Celsius, diha nakaposition ng ato mata is no parallax error na mo occur kay correct man siya ang pagposition ng ato mata sa pagkuha ng true value or measurement ng isa ka object na ato gi-measure. Pero kung ato mata is nakaposition siya sa low reading, mauna siya ang parallax error kay dili sakto ang position ng mata pagkuha ng measurement ng isa ka ng liquid thermometer, ng temperature ng liquid thermometer. Makakuha ta diha ng 68 degrees Celsius. Pero kung arsa ta sa high reading, parallax error gihapon ta kay kung i-measure nato diha, ang makuha nato is 74 degrees Celsius. So parallax error gihapon siya kay wala siya makaposition sa sakto na correct value. So mao na ang parallax error result to higher or lower reading depends on the position of the eye. So ang parallax error nakadepende na sa ato kita mga tawo na kung asa nakaposisyon or mali na pagkaposisyon sa pagkuha nato ng true value or correct measurement sa isa ka object. Mao na siya ang cause na mahitabo sahay na kalaw nato okay ra sa dili nato mapansin na ang ato di pagkuha ng measurement or temperature sa object is mali na di ay kay dili sakto ang pagkaposisyon ng ato mga mata. And then the effect of parallax error to accuracy when the parallax error when the measurement constantly use incorrect or mali na angle to view the marker, so mauto ang ato gi-measure is ma-misplace or ma-miss out from the true values by the same amount. Tapos ginatawag sa dyan si na systematic error. So always remember na dapat magkuha ta ng correct value or sakto na measurement. Dapat gyud ang ato mata is naka-center or sakto naas dyan sa sakto na position sa pagkuha ng isa ka measurement. Para ma-avoid ang parallax error, dili ta dapat basta-basta dadyo naka-position ang ato mata sa biskan asarakan. Kung di ta dapat na ang ato mata is sa center gyud, dili siya kung sa above, dili siya kung sa below naka-position. Meniscus is a curve of molecular substance when touches another material. Then also meniscus occur when adhesion is responsible to meniscus, and this has to do in a part with water fairly high surface tension. So ang meniscus has two types, which is concave meniscus, convex meniscus, na dapat nato i-consider because magdepende ini siya if the molecules of the liquid are more attracted to the outside material or to themselves. So, in concave meniscus, measure at the lowest level of the curve. Then, it is occurs when molecules of the liquid are attracted to those of the container. So, manang mahitabo sa water na naka-concave meniscus siya. So, sa convex meniscus measurement at the highest point of the curve, na which is mo-occur siya when the molecules have strong attraction to each other than to the container. And also, ang concave is water glass form and a concave meniscus due to strong adhesive forces. Then, ang convex meniscus, mercury and a glass form, a concave meniscus due to weak adhesive forces. So, ang concave meniscus mo form siya into due to the strong adhesive forces. Then, ang convex meniscus mo form siya due to the adhesive forces. So, pero, we need to remember na if mag-measure ta ng isa ka liquid thermometer, dapat gadyod na to i-consider na ang ato measurement is, ang ato pag-measure is naka-center to the and the meniscus, which is kanang makita na sa picture sa waters and sa mercury na even though concave meniscus and convex meniscus siya, pero pagkuha nato ng dapat ng measurement nila is naata sa ang ato eye position is naa sa meniscus para exact ang ato makuha na temperature or measurement sa isa ka object. Then, kibali kung sa accuracy and precision, kung magkuanta ato early sila duha, dapat sa pagkuha ng accuracy and precision, dapat gadyod ang ato mata is naa sa right position kung asa ang nakabutang ang isa ka object or unsa ang value ng isa ka object para maiwasan nato ang parallax error na mahitabo minsan na wala nato ma-realize na mali na di ay ang position ng ato mga mata or position ng ato body sa pagkuha ng measurement or temperature sa isa ka object.
Good day everyone, I am Navan Chu. I will discuss the three category of mathematical errors, which are the careless errors, computational errors, and conceptual errors. First is the careless errors. These errors are caused by not paying attention and working without properly checking the input data. Example is, we mistakenly put a certain value that are not included in calculation. Next is the computational errors. As we go on for calculation, these errors are committed when we misuse the operation like adding, subtracting, multiplying, and dividing. For example is, when we multiply many times the value that must be multiplied only once. And the third is the conceptual errors. These errors occurs when we misuse the formula and concept and we misunderstood the concepts behind the computation. For example is, the concept for computation is adding, but we use subtraction. How do we represent error mathematically? We can represent error mathematically through finding the difference between an experimental value and actual value by using the percent error. What is percent error? Percent error tells us how big are errors when we measure something in the experiment. For example, we have 100% accepted value. A 1% error means that we got very close to the accepted value, while 45% means we were quite a long way off from the true value. And the formula for percent error is equal to the accepted value minus to the experimental value over accepted value times 100.
Sample problem for percent error. Working in the laboratory, a student finds the density of a piece of pure aluminum to be 2.85 gram per centimeter cube. The accepted value for the density of aluminum is 2.99 gram per centimeter cube. What is the student percent error? First is, we need to look for the given. Then second is, we put the formula, which is the percent error is equal to the accepted value minus the experimental value over accepted value times 100. And then, we substitute the value to the formula, which is the accepted value is 2.999 grams per centimeter cube minus the experimental value, which is 2.85 grams per centimeter cube over the accepted value 2.999 grams per centimeter cube times 100. And then, we perform the subtraction, division, and multiplication. And the result is 4.97% is the student percent error. What is instrumental error? Instrumental error is an error that caused by the malfunction of devices or instrument that is used for calculation. When we measure something, we need some devices or instrument that can measure it, like weighing scale for weight and GPS for distance and other measuring tools. But there are times that it can encounter problems from their systems, and we need to check it properly before doing a measurement to avoid miscalculation and to have an accurate data.
So which is important? So if you are accurate, then it's good. But if you are only accurate, you will never reach the target of yours or goal. And if you are precise, which means you have good results because they are equally right, but the question is it close to the value? Or are you accurate? By this, we can say that both being accurate and precise is important, because first, you will achieve your task or goal. Second, you will avoid mistakes or faults. Lastly, you and your informations will become reliable. Next is sensitivity, which will be tackled by Amor Cantila.
Sensitivity is the ability to demonstrate the two samples have different amount of analyte. When we say analyte, it is the component of interest in the sample and it is an essential part of many analyses. A method sensitivity is a measure of its ability to establish that such difference in is significance. And sensitivity is applicable in all proper handling in sample preparation. Kay kada analyte or sample na tag-examine, gamay na difference sa kada result or analysis, dako na kayo an impact kung unsa ka accurate or precise ang examination or analysis. Kung suod ra ba or ladyo ra ba sa expected na result. So, ang sensitivity matters in all proper handling. Kay maka-establish man siya nan ini na sample layo ra kaayo sa expected na result or kanina sample is duol kaayo sa expected na result. Kibali kung asa ra siya pasok sa requirements. Detection limit is the lowest amount of analyte which can be detected or pinakagamay or gamay ra na amount of analyte ang iyahang ma-detect. And sometimes there are other aspects that causes sensitivity during sampling analysis. So, jaoy duha, so amo jaring sample preparation and the device use.
Hello everyone, my name is Clark Wendell R. Sabaldan. I'm here to discuss the remaining topics for our report. First is core logging. In sample preparation, isa sa pinakagamit o importante na method is core logging. Mga geologists ang nag-perform ani. So in core logging, is ang purpose ani niya is to give a certain sample using tubes or core barrel ang ginatawag. Itusok na siya or ginadrill, then kadto nga to nakuha na sample is mo process pag examination and analysis for easy identification of rock type. So all the drill hole data gathered is called logging. So that's why ginatawag siya na core logging. Sa ini na process is nag-require jud siya og proper handling sa pag-perform because ang tube or core barrel na ginagamit is dali ra mabalik. Ug sa dapat pagkatapos kuha sa sample is to put the core barrel into the core box. So next is analytical balance. As you can see in the screen, analytical balance is a measuring instrument to accurately measure mass. So ining analytical balance is very sensitive when using kay dali ra siya makadetect maski single grain of substance. Mauna siya na ay cover for making sure na dili maapil ang mga unwanted dust sa pag-measure and especially ang air if imo ginagamit sa pag-measure is in powdered form. So inana ka importante when using analytical balance in proper handling to be more accurate and precise ang result na ato makuha.
So I think that will be all for our report or presentation. I hope na you have understand something or learned something from our presentation. And thank you for listening to us.